Look at your hand. Make a fist. Feel the bone, the muscle, the weight of it. That solidity is a lie. You are not solid. You are a swirling cloud of atoms held together by one single number, the speed of light. 299,792,458 meters per second. Shift that number by 0.1% and the bond holding every atom in your body fails, not slowly, instantly. Your hand, your chair, the earth beneath your feet, every star burning in the night sky, all of it unravels into a formless mist of radiation in less than a heartbeat. The speed of light is not a traffic law for distant lasers and satellites. It is the invisible scaffolding holding up matter itself, and the entire universe just happens to be running the exact, hyper-specific number required to keep you intact. Convenient, isn't it? 14 billion years of cosmic improvisation, landing perfectly on the one configuration that does not kill everything. Lucky us. To see how this works, you have to look at empty space. Empty space is not empty. It is a taut fabric with a hidden tension. Imagine a trampoline stretched tight. Even with nothing standing on it, the surface has a built-in stiffness. In the vacuum of our universe, that stiffness has two names: electric permittivity and magnetic permeability. Two strange properties of nothing. In 1865, a Scottish physicist named James Clerk Maxwell did the math on those two properties. He noticed something. Push on an electric field and you create a magnetic one. Push on a magnetic field and you create an electric one back. They leapfrog over each other, racing outward like a ripple on water. When Maxwell calculated the speed of that ripple, using only the stiffness and density of empty space, the number that fell out of his equations was exactly the speed of light. Light is not a thing traveling through the dark. Light is the vibration of the dark itself. But here is where it gets uncomfortable. Buried inside the speed of light is a deeper number, a pure ratio, no meters, no seconds, no units at all. Physicists call it the fine structure constant, alpha. It comes out to roughly 1/137. Think of alpha as the volume knob for how loudly light and electric charge talk to each other inside every atom. Turn it too low, electrons drift away from their nuclei. Matter goes loose, then gone. Turn it too high, electrons crash inward, chemistry seizes, no molecules, no biology. No one alive to ask the question. The dial sits perfectly at 1/137, not 1, not 10, not a violent number, a small disciplined number. The exact setting where atoms have size, molecules have shape, and chemistry has enough room to become blood. Randomness apparently took the engineering exam and aced it without studying. For something with no plan, this dial keeps passing inspection. The plot thickens when you look at the cosmic oven responsible for building your body, the stars. In 1953, the astrophysicist Fred Hoyle hit a wall. Carbon, the element you are made of, the element every plant, every animal, every cell on Earth is built from, should not exist in the amounts we observe. The math said stars could not produce enough of it, but carbon is everywhere. So the math was hiding something, Hoyle reasoned backward. We exist. Carbon exists in abundance. Therefore, stellar furnaces must produce it. Therefore, the nuclear pathway must work. Therefore, carbon-12 must possess a very specific, very narrow energy resonance at roughly 7.65 million electron volts that lets 3 helium nuclei slam together at exactly the right energy to fuse. A microscopic, flawless bullseye. He predicted it on the spot. A few years later, William Fowler's team at Caltech measured the resonance experimentally. It was there, almost exactly where Hoyle had predicted. Fowler shared the Nobel Prize in Physics in 1983, partly for that work. Now hold that against the speed of light. Nuclear binding energies run through C because energy equals mass times C squared. The Hoyle resonance, the bullseye that manufactures every carbon atom in your body, is anchored to the speed of light. Shift C by less than 1%. The bullseye slides off target. The helium nuclei miss. Carbon production across the entire universe collapses to nothing. No carbon, no oxygen, no water, no planets, no blood. To picture the precision, imagine flicking a coin across the Milky Way galaxy and having it land perfectly on its edge on a distant planet. Now multiply that by the dozen other constants this depends on: electric strength, quantum scale, particle masses, nuclear forces, gravity, the expansion rate of space itself, each one threaded into the others, each one landing exactly where matter becomes interesting instead of dead. This is not one lucky coin toss. This is a locked safe with dozens of wheels, every wheel turned to the precise combination that permits existence, and the safe opening cleanly on the very first try. Random forces with a remarkable quality control department. We are expected to look at a perfectly tuned grand piano, hear a flawless sonata played from across an empty room, and conclude with a straight face that the wind simply blew through the strings just right. So ask the sharper question. If reality is balanced on a wire this thin, what exactly is holding the wire steady? When humans try to replicate even a microscopic fraction of this stability, we fail spectacularly. At CERN, deep beneath the border of France and Switzerland, sits the Large Hadron Collider, a 27-kilometer ring of superconducting magnets cooled to 1.9 degrees above absolute zero, costing nearly $5 billion to build. Its entire job is to accelerate tiny protons to 99.999999%, the speed of light, the undisputed peak of human physical engineering. It holds that precision for fractions of a second, while consuming the electrical power of a small city, while requiring continuous teams of engineers correcting the system in real time. A single hydrogen atom maintains the equivalent calibration permanently, for breakfast, for 14 billion years, with no staff. In December 2022, the National Ignition Facility in California fired 192 lasers simultaneously, focused to a point 2 millimeters across, timed to within a nanosecond, and finally produced more fusion energy than the lasers used to ignite it. A milestone decades in the making. The apparatus fills a building the size of a stadium. The sun performs the same reaction continuously, in a volume the size of a grape, and has been doing it for 4.5 billion years. No lasers, no Grant cycle. In 1999, at a Harvard laboratory, the physicist Lene Hau managed to slow light down to 38 miles per hour by shooting a laser through a cloud of sodium atoms chilled to within a millionth of a degree of absolute zero. A magnificent feat of physics, but she did not change the speed of light. She forced it to slog through an artificially frozen swamp. We cannot touch the vacuum speed. We cannot move the cosmic thermostat. The dial that protects the structural integrity of every atom in existence is locked, and the key is missing. An accident that left operating instructions inside the wreckage. Bold alibi. You are sitting inside a reality built on a razor's edge of physical impossibility. The speed of light is not a number on a classroom wall. It is the permanently locked thermostat of the universe. It governs the exchange rate between matter and energy. It sets the tension of empty space. It anchors the dial that lets your atoms hold their shape. It writes the rules that let stars manufacture carbon. It carries information across galaxies clean enough for a human brain to decode it. We are told the universe is chaos, that out of infinite random rolls of the cosmic dice, this exact configuration just happened to fall out of the dark. The numbers do not agree. A locked safe with dozens of wheels, everyone dialed to the precise combination that permits biological existence, opened cleanly on the very first attempt. You do not get this from an explosion. You do not get this from chaos. Look at your hand one more time. Look at the impossible, breathtaking solidity of your own existence. Who calibrated this if no one calibrated it?